quadratics a long time ago. Yeah. Quadratic formula, or not just quadratic formula, but when you're talking about quadratics, any quadratic is going to be anything that you can write in the that form ax squared plus bx plus c. That was your quadratic stuff. That was standard form. You vaguely remember that. We also had the AH and K with that, where you had what was called vertex form. I'll put y on the other side, it looks weird. You vaguely remember that? Where H and K were your vertex, or the vertices, the points of the vertex, excuse me. And then the other one we had was intercept form. Remember that one? No? Intercept form was A where P and Q, let me move this out of the way here. They were your x-intercepts. They were the zeros of the function. So if your 0 was at 2, remember we said zeros and we would go terms all the time? Your 0 was at 2, your term was x minus 2. If your 0 was negative 3, your term was x plus 3. We've done that. It's just a little quick refresher here. What's that? But that's called intercept form. So this is, let me label these again here. We have standard, vertex form, and then intercept form. The value of A, if it was positive or negative, it told you what direction it was moving, up or down. Other than that, everything else was pretty straightforward, if you remember it. I know, that's a lot to ask.
I don't think I did.
Well, you'd be surprised. You'd probably remember when I show you this next piece. Writing an equation of a function in vertex form. Excuse me. So what I want to do here is I'm going to have a vertex and some point on the curve. And if I know that information, I can write the equation of the curve. Just by that. Because your vertex plays the role of h and k. You agree? All right. So if I start out with an h and k at 2 and negative 3, if I substitute in, I get y equals a x minus 2 quantity squared minus 3. You okay with that? Yes. All right. Now, I have an ordered pair on that curve. What's that ordered pair? I don't know if you can see it. So the point that I have on that ordered pair is at 4 and 1. What does the 4 and 1 represent? X and y. What does that allow me to solve for? Very good. So what this is going to do is that if I substitute in for x and y, I can solve for a, and then I can write it in vertex form. So you're basically given 4 out of the 5 variables in that whole jumbled equation of intercept, or excuse me, vertex form. Y equals a x minus h quantity squared plus k. You've got 4 of the 5. Find the 5th one and rewrite. So this is where math gets fun. What's 4 minus 2? 2. What's 2 squared? 4. Good. So we have 1 equals 4a minus 3. What's a? 1. So now you can write your equation. Do I have to put a 1 there for a?
No.
If I do, is it a big deal? So my final answer would be y equals, I'll put it in there just to make you happy.
X minus.
And there's your answer.
But it's kind of weird, you don't even have to space
And that's it.
That's pretty good.
Does it get harder than this?
unless you don't know how to add or subtract or square.
Do we get a calculator to this out?
You guys didn't worry about calculators. I love the fact that I have you trained so well. This is great. You'll make pre-calc teachers happy.
Wait, how would that make them happy?
Because that means you're ready not to use your calculator.
Oh, I thought they always asked because they wanted to.
No, it also means that you're willing to do mental math.
You don't put the word there. It's a line.
Let's try another one. I'm going to do the same basic idea where I have y equals a x minus h quantity squared plus k. I want to write it into the vertex form, given the vertex and a point. Why are you guys arguing? Don't make fun of her. What are you guys whining about?
I said we don't argue this out.
It's because you guys got a good view of the nice, beautiful weather. It makes you happy.
It does.
You guys are cranky when it's crummy out.
Real talk.
The biggest mistake you guys are going to make with these types of problems is you're going to flip-flop an x and a y, or put h, or you're going to call this x and y and call that h and k. Don't do that. So when you write it out, take a second, if you will, and just label what everything is.
Quite longer, quite longer than I probably should have about which one's X and Y.
Just remember what comes first in the alphabet. So we have 3 equals a.
Yeah, but I wanted to put 4.
Oh no, what is 4 minus 2?
What?
You're getting ahead of yourself.
I'm way ahead of
Oh! So you're better than all of us.
Wow. I'm a badass over here. I got it. I'm sorry, Dustin.
That's okay.
That was awesome. That was awesome. Oh man. What's A? No, it's not always going to be 1. It's item. So y equals x minus 2. Okay. Not bad? Let's do the next one.
Yes, let's do the next one.
Right, we're going to work with the quadratic given zeros at a point. So if you have zeros at -2 and +3, and I know we've done this many times, especially when we talked about polynomials, when we would start worrying about our synthetic division. If I have a 0 at -2, what's my term?
2.
X plus 2, that's what I was looking for. If my 0 is at 3, what's my term?
X minus 3.
Perfect. So in this case here, I know that y equals a x plus 2, x minus 3. And what's the ordered pair they give me?
-1, 2.
What do you think I'm going to put in for x and y?
-1 is
something.
X, and 2 is Y.
What am I going to solve for?
Hey!
Hey, you're right. What are you going to screw up?
Math.
Besides that?
The points.
No, the simple addition and subtraction is really what I was going for, but that's okay. If you'll notice when you're working with intercept form, you've got 2 terms already in parentheses. I'm thinking whether I give you a smart calculator or a dumb calculator, you could probably put in parentheses -1 plus 2 parentheses, -1 minus 3 parentheses, and hit enter, and it will give you the right answer every time if you type it in the way you write it. So hopefully you get -4.
Yeah.
Wait, what?
Or you could do it in your head.
Well, you don't want to do that in your head because math is hard.
I had it right. I said that.
So what's A?
I said it was
-1/2.
Wait, what was the version?
So So my value of A is negative 1/2.
It's fine.
So then I just go back and rewrite it out with the A value.
Well, you're trying to steal that.
Oh my God.
And you're done.
So hard.
Why didn't I ask you?
This is fun.
It is fun. It's fun with functions.
What? Oh, then.
You want to know the turned down math t-shirt? We wanted to have this one, but we really thought it'd be bad.
That's good, that's good.
Thought it was clever. Just didn't think administration would like that too much. I paused it.
I know, that's why they're
Already in our class, they watch
Trying to explain.
All right, let's try and make this a little bit more difficult then.
Trying to explain.
Carissa's getting bored. Oh no, then we'll have to really make sure we take care of this. I'm going to do this completely different now. I want to set this up in such a way that I'm going to write an equation of a parabola, quadratic, if I know 3 ordered pairs. When I go with standard form is your ax squared plus bx plus c equals y. Do you agree? Yeah. All right. Now, if I have 3 ordered pairs, I can have 3. Since I have 3 x and y values, I have 3 separate equations. I have 3 x and y values, so therefore I can have 3 x and y equations to generate my a's and b's. So if I use each one of these sets as ordered pairs, what if I substitute in x's and y's? What's negative 1 squared? 1. So I get 1a minus 1b plus c is 5. All I'm doing is substituting in. I go to the next one. What's 0 squared? 0. No a plus no b plus c is 3. C is 3. What's 3 squared? 9a plus 3b plus c is 9. Yes, sir.
So for the first one, we had -1. Why was it squared?
Correct. So what this is generated, this around here.
Always
What this is generating is a system of equations with 3 variables, a minus b plus c is 5. C is 3. 9a plus 3b plus c is 9. Ooh.
Could you sub in
Yes.
C and then only have 2?
Yes. And that's the idea here. There are many ways of solving systems of equations. I don't know, did you guys ever do a 3 by 3 system of equation? Really?
Yeah.
Maybe.
Huh.
I don't remember it.
Like this extra credit.
Yeah.
I don't know.
I'm surprised by that. Huh. I should probably do that next year. Do you guys a little bit earlier in the year then? Okay. So, like Jerry was just saying, if I want to start using substitution stuff, let me put on a separate screen here. I'll dual page it out. We know that C is 3. Are we okay with that?
Yeah.
So if I do that, I have A minus B plus 3 is 5. So A minus B is 2. We all right with that? Therefore, what do I know that A is?
2 plus B.
B plus 2, 2 plus B. We're okay with that?
Yeah.
All right. If I substitute in the 3 value into that second equation, I have 9A plus 3B plus 3 is 9. We okay with that?
Yeah.
Rewrite it again. 9A plus 3B is 6.
Would you divide by 3?
Absolutely, absolutely. In this case here, what Phoebe was saying is that she's just going to take out a GCF. Do you need to? No, you don't. But does it help out a little bit sometimes? Sure. By all means. If you don't do it, it's not that big of a deal. But we might as well take it out. So we'll divide everything by 3. We get 3A plus B is 2. Knowing A is B plus 2, we substitute it. You okay with that?
Yeah.
All right. So we have 3 times B plus 2 plus B is 2. Very good. We have 4B plus 6 is 2. What's B?
-1.
Excellent. So we know that C is 3, B is -1, A will become, well, what's -1 plus 2?
1.
1.
1. So now you have your coefficients for A, B, and C to put into your quadratic equation. And you get the answer, because your standard form of the equation has your A, B, and C. How to get the A1? We took the B was -1, I substitute back in where A was B plus 2. So then I'm done now with 1x squared minus x plus 3 is y. And there's my equation. Yeah, Michael?
No, I got lost after you did the B equals -1.
What I did there was, on this side here, I took the B equals -1, and I substitute back up where I did, where I shoot up, where A is B plus 2, so I substitute in there to get A. All right. So the messiness comes from all of these when you have to do the 3x3 system of equations.
Will one of them always be like a 0?
Oh, no.
Man.
Oh, Lord.
That's cool.
Oh, you guys are gonna hate me. But that's okay, I'll do
We're
it.
gonna hate you. Why are we hating you again?
Because I'll show you.
Okay.
No.
No.
I don't like this one.
But I'll get over that.
I'm just saying, what if I don't?
No. Should we do that?
You just, oh,
He's a teacher. Come
How
here.
to use that on
There's gonna be a whole bunch. When you do this, is it always gonna be standard form?
No.
yeah, with the 3 points, you're gonna go standard form.
Okay. Oh, is this one a fraction?
I don't know, it might.
This one probably has fraction.
Yeah, Michael?
Would it be the same if you just drew it out?
Yeah, but you still have to, it's not gonna give you, we don't know any one of those is if they're opposite one another, to give you that axis of symmetry to work yourself backwards off of that. So we don't know if we can figure out that B value in any of that. So we started again. What's -2 squared? So we have 4A minus 2B plus C is -1. That's my first equation. My second equation is A plus B plus C, because x is 1
Oh, right.
Equals 11.
equals 11. We have 4A plus 2B plus C is 27.
Okay.
Now, there's a lot of methods to using systems of equations. If you guys remember, one of the things that you can do is what we call linear combinations, or adding or subtracting, things like that. If you take two equations to eliminate a variable, you're looking for to have the same coefficient with same signs or opposite signs. In this example, I want you to notice how you have a negative 2b and a positive 2b. If I add those two equations together, what happens to the b's?
They cancel.
They drop out.
Then there's one.
Wait, could you also like multiply the first one by negative and then get rid of both the 4a and the c?
Yes, you can do that as well. That should probably be quicker.
No, maybe.
Here's what Phoebe was saying. Phoebe recognized this. If you look at the first and third equation, if I take the first equation and I multiply it by -1, I get negative 4a plus 2b minus c is 1. Everybody okay with that? I just multiply everything by -1. Take that third equation and add it to it. What happens when you add these guys together?
You get 4b equals 28.
What's b then?
7, I think.
That was a good pickup. I didn't even catch that. She recognized that she could kill two birds with one stone. Multiply that top equation by -1 and add it to the third equation. Two variables drop out. You get one of them set up. Now it's a system with two equations with two variables, which should be rather quick because you know what b is. If b is 7, I have a plus 7 plus c is 11. So a is 4 minus c. And then it's really fast.
So then we'll see.
So now you know, it doesn't matter. At this point then, you know what, you know b is 7, a is 4 minus c. So if I use this one here and go 4 times
Doesn't matter
4
if you
minus,
use that?
it doesn't matter. I would use, because you've simplified this one into here. Just go back to this one down here. You know that b is 7, so it'd be plus 2 times 7 plus c is 27. What you're doing here is just going to solve for c. So you have 16 minus 4c plus 14 plus c is 27. So negative 3c, 30. See if c is 1. So if c is 1, what's a?
3.
3. So a is 3, b is 7, and c is 1.
What was the other way?
The way I was originally going to start, eliminate one variable at a time. It just so happened, I just didn't pick out the fact that I could have gotten two of them with one shot. And sometimes that happens. If I would have done it originally my way, it would have just taken one extra step, that's all. It wouldn't have been that big of a deal. Hopefully we would get the same answer. Then the regression part. This is the easy part when you go to your calculator. Tables. We did this. Remember we had the word problems, we would estimate like how long it would take something to fall, or how long it would take to reach the other side. That's these problems. That's these things where we are setting these things into our L1 and L2 of our stat lists. Coming up with instead of using linear regression, with what are you going to press? Okay. Quadratic regression.
How do we get there?
How do we get there? Again, when we set this one up, we're going to get the equation of the line of best fit. Oops, wrong button. Stat, edit.
And then,
Alright,
Stat, edit, and then just put those in. So I move this up. Oh, boy, oh, boy.
Wow.
That is the I'm not messing around calculator screen. Just trying to move it up out of the way.
And then you go to, then you do the quad.
Yeah.
Got
How do you figure this?
Oh, I done messed up. You're right. There we go.
Wait, how do you figure the list?
You can just hit delete second on each one.
Yeah. Then you hit stat again. We're gonna calculate
Later, quad.
quad reg.
You didn't keep it.
Ah.
Quad.
There's our A, B, and C then. Now, what happens with this, take these A, B's, and C's, and when you write out your equation, because we're going to use the table then to figure out the next parts, make sure you round out to 2 decimal places, okay? So I'm going to take this to the next screen, because that's where the next question comes in, where it's use your model to predict average sales. When does the model predict the house price will reach 200,000?
With the 2 decimals, you said?
Yeah. So if you're putting this, if you're substituting this back in, if I have that, I have y equals 1.83x squared minus 19.55x plus 172.73. I put that into my y equals part, and then it's looking for predicting when the house prices will reach $200,000. The only thing is, you just have to be careful about where were your years. Did it start at year 1, year 2? What did it start at? So I think ours started at year 0, went up 2 years. So year 0, I think in the word problem itself, started in 1988. So this was 88, 90, 90, and so on. You just got to figure out what, as you're counting itself up, where it's going to run at. Now, if you've already changed your table set,
What year are we going to?
I think it said for, we want your Y value to be the 200,000.
12. 12 is X, I think. Or 9.
Yeah, 12 should be X. So if I substitute that in, what we have 1 point. I swear there's a button to do that, and I forgot how to do it, so I apologize for forgetting. I'll figure it out. There is a way to send this equation to the y equals, and I forgot. I'm sorry if I failed you. And then I gotta change my table. What were you looking at for, we need, I'm looking for 2,000, or 20,000, 200,000 in our, about year 12, so that would have been 19, or 2,000.
2000? Okay.
Because 12 plus 88 is 0, right?
Yeah, very well be 100 technically.
Yay.
Damn.
The only other thing on here was they talked about the, use your model from part A to predict the average sale price of the house in 95. That just means you have to figure out the X value. Well, I'm looking at part B there.
95.
It's for 95, that means your X value would be
For some reason I thought it said 55.
7. Yeah. So you can,
145,000.
so you can substitute 7 and go from there. Okay? I don't think this is going to be really difficult to do. The worst part's going to be using those matrices, not matrices, the systems. Try those out. You should be able to figure that out with relative ease. Oh, I didn't write that on there. You know, 2 wrongs make a right, so I'm batting 1,000 right now. It's 309. Oh, you know what? I gotta add make the system one in. Yeah, I do.
You know what, Matt? Three left.
Oh,
Okay.
We're looking at a
I
square.
know.
Yeah, 39 or 29 and 31 are the system equations. I gave you 2 of them. Yes, ma'am.
this folder is so solid.
My calculator is tweaked.
Tweak it.
Yeah, it's not
This is
letting me, it's not letting me
tweaking,
create my
tweaking
table.
low.
It's saying
Run up
there's
on
an
it,
error.
get to squeezing.
Yeah, it's weird.